Hi, good night. We are team number two, and now we are going to expose our final problem situation. Well, our team is composed by me, Angel Bringas, and my teammates Daniel Garduño and Luis Fernando Fonseca.
Well, to start, we have the background. The main topic that we'll be addressing this project is electromobility, focusing on two types of batteries, lithium batteries and fuel cell batteries, which are found in hydrogen cars, in hydrogen powered cars, but we will also talk a little bit about combustion cars. Now, to start with the pros and cons, we have electric cars. Well, they started with limited range, but as time has passed, they have proven to have many improvements, such as a better range, less charging time. The main problem with this type of cars is the pollution towards the environment and in its production and the pollution that the electricity generates.
Well, we also need to talk about the hydrogen-powered cars that are the ones that use fuel cells that convert hydrogen into electricity, and well, as a product, they emit water vapor.
Well, the evaluation of colligative properties and our problem situation, we can have antifreeze that it is a glycol-based fluid mainly composed by ethylene glycol or propylene glycol. These rely on colligative properties to work correctly because with the mixture of ethylene glycol and water inside the car's radiator, the freezing point suffers a depression and the boiling point and elevation. The most common composition of the antifreeze is the 50-50, 50% water and 50% glycol. And with this mixture, you have a range protection of -37 degrees to 106 degrees. A change of another composition could be if the conditions of the climate of the weather are extreme, but you can consult that in the user's manual of your car.
Well, also we need to mention that ethylene glycol is the preferred solid in commercial antifreeze because of how well it changes both the freezing and boiling points of water in an engine to cool or gain more heat. Well, also we need to mention that in electric cars with lithium-ion batteries and fuel cells, coolant is the one that regulates temperature to prevent overheating, ensuring safe and efficient performance. And well, the chemical composition of these coolants is basically based on glycol compounds, primarily ethylene glycol or propylene glycol, combined with additives to prevent corrosion, scaling, and microbial growth.
Well, the about the endothermic and exothermic reactions, we have that the endothermic reaction occurs when the chemical reaction absorbs heat from the environment, and that same energy gives the activation energy for the reaction to happen. And in addition to that, the products will have higher energy than the reactants, meaning the change in enthalpy will be positive. On the other hand, we have exothermic reactions, that it is when energy is transferred to the environment and the energy is released in the form of light or heat, and well, the change in enthalpy will be negative.
Well, to start, we have the combustion reactions that happen in normal conventional cars. What happens here? We have three different compounds, hexadecane, octane, and ethanol. First of all, we balance those equations and the reactants and the products. And finally, uh, once that is done with the table of enthalpies, we get the values and calculate the enthalpies of the reaction. And now, in order to address its efficiency, we can see that the one that is more negative is going to be the one that is most efficient. In this case, it goes from hexadecane, octane, and finally ethanol. Now, we're moving on to the batteries that are found in the different types of cars. This one is the type of battery that is found in conventional cars. The lead battery, well, the cathode reaction, in this case, is also the reduction reaction, as lead dioxide gains two electrons and is reduced to lead sulfate. Now, the anode reaction, in this case, is the oxidation reaction. Lead loses electrons, in this case, two electrons, and it oxidizes into lead sulfate. Now, an example of an exothermic reaction could be when discharging lead dioxide and spongy lead react with sulfuric acid to produce lead sulfate and water, releasing energy as electricity and heat. Now, when do we apply the batteries and where does the energy of our car come from? Well, first of all, whenever we start our engine, it comes from the battery, the energy, and if the engine is off, also the electronics are powered by the same battery. But once the motor is active, the electronics switch into the alternator that is constantly producing energy with the help of the mechanical energy produced by the engine.
Well, now about the lithium battery, we have that the materials for construction of the lithium-ion batteries for electric vehicles feature a lithium metal oxide cathode, a graphite anode for ion storage, a lithium salt-based electrolyte, and a porous separator to enable ion flow while preventing electrical contact between electrodes. An example of an exothermic electrochemical reaction, it could be whenever the battery is being used to power the electrical motors and whenever the electronics are being used.
Well, also we need to talk about the hydrogen fuel cells and their composition of the materials of which they are built. Well, they are built of carbon electrodes coated with platinum catalyst, a proton exchange membrane, a gas diffusion layer that it can be carbon, paper, or cloth, bipolar plates such as graphite, steel, or composites, and seals or gases like silicon. And well, here as an example of our reaction, and as my teammates have already mentioned, the anode one is the one that produces the oxidation, in which hydrogen gas is split into protons and electrons at the anode. And well, also the cathode is the one that produces the reduction, and is when the oxygen gas reacts with protons and electrons to form water at the cathode.
Well, how can you determine which element is reduced and which one is oxidized? Well, a way to would be by the oxidation number. So if its oxidation number increases, it is oxidized and it is the reducing agent. And if the number decreases, it is reduced, meaning it is the oxidizing agent. An element oxidizes whenever it loses electrons and it reduces whenever it gains electrons.
Well, finally, here are our reflections after concluding this project that you can check them pausing the video if you want to see them. Thanks for your attention.
Thank you very much.
Thank you very much.